Hi there, in this video we will try to solve the final term exam of Introduction to Mathematical Methods in Economics. The course code is 2205 and it was held in GCUL University, Lahore. So let's see the questions. The question paper is as we show in this view. These are the various questions and they are 12 questions. We will try to solve all of them, though there are some questions to be left on choice, but we will solve all of them. The first one is about the demand supply function. They are given. This is the demand function, this is the supply function. We required the equilibrium price and equilibrium output. So we equated these two, and this is the basic condition of equilibrium, the conditional equation of equilibrium. And then we substitute these values of demand and supply, and simple algebra will allow us to have the answers of equilibrium price. And once we have the value of equilibrium price, we can also find the value of equilibrium output either by putting this value in this equation, that is the demand equation, or the supply equation. So we chose the demand equation in the first place. We substitute the value of equilibrium price in it, and we found the equilibrium output, which is 138/7. So further work is left for you. You can try to find the equilibrium output by using the supply equation, and we can put this value here. And this is a small DIY for you. Do it yourself and try to find out that the answer of Q status is the same or not. That it should be the same, but the verification is quite useful and affirming. Then we have question number 2. Again, we have to find the equilibrium national income and equilibrium consumption. So we use the given data. This is the expenditure approach of GDP. This is the consumption function. This is the investment equation, and this is the equation of government expenditure. All of the information is given. We note the information of these 4 equations, and then we substitute the values. Here we substitute the consumption function, here the value of autonomous investment 16, and here the value of government expenditure, which is autonomous in nature, of 14. After substituting these values, simple algebra will guide us to find the value of y. However, we do not have a usual equation here. It's a kind of equation that has a fraction in its power. So we can assume it equal to some other value which will make it a quadratic equation. For example, in place of 0.5 we can assume 1, another variable, for example z, and here automatically in place of power 1 there will be another variable z, but with a power of 2. So considering these two equalities, we can substitute, and using these auxiliary variables, that is z and z square, we can solve this equation. And here we can see simple factorization is done. You can pause the video and try to understand this basic step. And then we have two values of z. One is a positive value, the other is a negative value. Negative value, as we know, for national income will be meaningless. This is why we drop that value and we consider the positive value of z. Then we remember that z is also equal to y raised to the power 0.5. So we substitute this value here, and then we can solve this by squaring this. We will get y is equal to some other value, and that will be the square of 11. And here we are. Y status is equal to 121, where status stands for the national income at its equilibrium level. We can also find the equilibrium level of consumption simply by using the consumption function which is given, and by putting the value of y at equilibrium in its y original symbol. So here, by putting this value, we get this certain answer, and this is the equilibrium level of consumption. So this is how this question can be solved. Third question is about finding the average and marginal functions for that certain total product function. This is the production function which is given. In order to find the average product, we will divide this with the independent variable which is labor, and once we divide it, we'll get a simple answer which is the average product of labor. Then we have the marginal product of labor, and that can also be done simply by taking the derivative with respect to labor, which is the independent variable, on both sides, and we will get the marginal product of labor. So in this way we can find these two variants of the total product function. Then we have this utility function, and we are required to find the marginal utilities of the individual goods. Here we have two goods, x1 and x2. So marginal utilities are to be found. So primarily we will do this differentiation with respect to x1, which is the first good, on both sides. And once we see here, we see that there are two terms being multiplied, though both of them have different variables, that is x1 and x2. But since we are differentiating here with respect to x1, so this x2 term will be treated as a constant. Still, we include this in our detailed process of solving the product rule situation. So primarily the derivative of the first term and the other term as it is, and the derivative of the second term, the first term as it is. This will give us a 0 because x2 when differentiated with respect to x1 will give us a 0, as it is considered as a constant. And finally, once we get rid of this term and it becomes 0, we will get this answer, which is simply the marginal product, the marginal utility of first good. So now it is more precise. This is the marginal utility. So next is the marginal utility of the second good, and for that we are differentiating the function with respect to x2, and here we have the same sort of product rule. Differentiating the x1 term with respect to x2 will give us 0, whereas differentiating the x2 term with respect to x2 will give us a non-zero answer. This simple partial differentiation, you can pause the video and see the results. So this will be the marginal utility, and this is of the second good. Here an interesting thing is that marginal utility of the second good does not only depend upon the second good, but also the quantity of the first good. Here the same thing holds. The marginal utility of the first good is not only dependent upon its own quantity, rather the quantity of the other good as well. It shows complementarity between the two goods, that is x1 and xy. So this is another useful piece of information, that the two goods work in collaboration to give an individual utility. Now we have the fifth question. We are given a certain demand function. It's a more elaborated demand function because the price is not the only determinant. Instead, income is also one of the determinants. We are also told about the price, and the income is also given. So here we note the given elaborated demand function, and we are required to find the price elasticity of demand. So for that we need the derivative of the given function with respect to price. The first thing is this. So we find the partial derivative of the given demand function with respect to price. We can do this and we will have the answer, which is -2. Then we are required the value of Q and P in order to put in the formula of elasticity of demand, is the price elasticity of demand specifically speaking. So we are given the value of P, but we do not have the value of Q. For that we can put the value 2, and then price is substituted here, Y is as well. Once we do this, we will have the value of Q. This is the value we were looking for. And now we have all the values. The derivative is there, we have found it already. The value of Q is just found, which is 160, and the value of price is already given in the given data. Putting all these values, we will get this expression. We can solve this and we will get this answer. Now this answer has two parts. One is the negative sign, which shows the negative relationship between quantity demanded and price, which is the reflection of the law of demand, whereas the magnitude is less than 1, which means that this is less elastic. Once the price elasticity is less than 1, it means that we are dealing with some sort of necessity that even if the price increases by 1%, the the decline in the quantity demanded will be less than 1%. So this is the real life interpretation of that question. The next question is quite related to the question number 5, because the same demand function is given, whereas we are required to find the income elasticity of demand instead of price elasticity of demand. So we will change the requirements accordingly. The differentiation will be done with respect to income, because income elasticity is required. So this is another simple process of finding the partial derivative, and it is with respect to y. This will be the answer, because p will be considered as a constant. Now we need q and y, because y will be in the denominator. So q is already found. We did this in the last question, so we can save this, and y is already available in the given data, as you can see here. So here we are, the formula is inverted accordingly. We have the derivative of the demand function with respect to income in the numerator, and the average demand function with respect to income, or q over y, is in the denominator. This is eta, that shows the income elasticity of demand. Once we substitute all the values that we have found and they are given, we will get this value of the income elasticity of demand, and this is less than 1. Once this is less than 1, it means that we have a positive sign in addition to this less than 1 magnitude. So positive sign means that increase income will increase the quantity demanded, but the magnitude is less than 1. This means that the the intensity of the elasticity is less. It means that the good is some sort of normal good, because a decline in income is not affecting much of the demand of the certain good. So this can be one of the possible interpretations of this answer that we have found. And then we have question number 7. So this question number 7 is there. We are given an average cost function. We are required an MC, that is marginal cost function, and we are also required to interpret this in terms of short run and a long run. So this is the average cost function which is given. In order to find out the marginal cost from this, we need to find out the total cost from this firstly, and then we can take the derivative in order to get the marginal cost. So the total cost formula is this: average cost into quantity. So the value of average cost is substituted, and then we get the total cost. Total cost, when we differentiate this with respect to q, we will get this answer. And this is the marginal cost, evidently, because the derivative of the total cost. So we have found the first part of this question. The other thing is that the given demand, the given average cost function is this. In this, we can see a fixed value, that is 174. And we know that in the long run, the fixed component of the cost does not remain fixed, because in the long run, there is quite a bit of possibility of inflation, or increasing rents, or increasing wages of security guards, or increasing utility bills of the production plants due to some extension, because new plants can be built in the long run. So the fixed cost, which is usually fixed in the short run, may not remain fixed in the long run. So this fixed value shows that we are not talking about the long run, we are talking about the short run. So it's a short run average cost function which is given. And the total cost function here can be seen, and this doesn't have any variable constant term. So this can be interpreted as a long run cost function, because it has the absence of any fixed or constant value. Now we have the total cost function. We are given this total cost function and demand function, and we are required to find the profit maximizing level of Q status. So the critical value of Q is to be found, and that should be adjacent with the maximized profit. So profit will be here. This is the cost function. This is the demand function. and this demand function is usable in a certain way. As we will see, the profit function is equal to revenue minus cost. Revenue is equal to price into quantity. We are given the variables in terms of Q, so we have to retain Q. So we cannot substitute this Q here because this will bring P instead of Q. We need Q. In order to retain Q, we can substitute P instead. So inverting this, we will get P is equal to 100 minus Q, and that we will put here in place of P. So here this is the inversion that we did, and we found the value of P instead of Q. Now we will put this value of P here, and the Q will remain as it is of the formula of revenue, and then the cost function is in the parenthesis. Now the remaining process is simply the calculations and simplification at algebraic level. So this is easy for you to understand. You can pause the video and see if it is done precisely. Simplifying, we will get the profit function, and then we come to the first order condition because we have to maximize the profits. So first order condition, the second order condition are to be applied. The first order condition requires the derivative equal to 0. So we have done this, we have found the derivative and we equated it equal to 0. And then by equating it equal to 0, we get the critical values. And the critical values are these. You can solve this quadratic equation easily and you will get the critical values. Then the second order condition is to be found taking the derivative of this function, that is the first order derivative. We will get the second order derivative. This is the second order derivative. Now this is not numerical in nature, its positivity or negativity will guide us about the maximum or minimum. So in order to make this a numerical value, you need to put the value of Q. We have already found the values of Q. There are 2 in number. So primarily we put Q is equal to 1, and then we put Q is equal to 11, and then we find the numerical value of the second order condition. So here we have found a positive value, negative value. Second order condition, if it is positive, signifies a minimum, and when it is negative, it shows a maximum. So this is the part we are interested in. We are interested in maximizing the profit, so we put the critical value, that is 11, in the profit function, and we get this answer. So this is the maximum of the profit. Whereas if we substitute this value, that is 1, in this case, we will get a negative answer. So this is a minimum level of profit. This remains something economically meaningless. Still, we have done this for the sake of mathematical completion. Now we come to the next question. This question is difficult to solve because in my estimation this question is not correct. I have tried to solve this, and I'm leaving this incomplete solution in front of you. You can try to solve this and comment in the comment box if you have found the solution of this question. But to me this question is not correct. There is some problem with this question due to which it's not getting solved. So we come to the next question, which is based upon a two-product firm which is facing demand and cost functions. So this is the demand function. These are the two demand functions. This is the cost function. Now we list down all of these, and then we can try to find out the maximum profit. Here we are given two demand functions and the cost function. From these two demand functions, we have extracted the values of P1 and P2, which will allow us to find out the revenues, because in order to find the profit, we need cost, but we also need revenues. So for that, we extracted the value of P1 and P2. And for that, what we have done is we have equated these two P2s, for example, equating these two, we got the value of this equation, that is P1, and then we can extract the value of P1 from both equations and then equate them in order to get an equation in terms of P2 and Q1 and Q2. So this is this couple is basically found by finding the simultaneous solution of these two by equating P2s and P1s. So you can do this by pausing the video and you will get these two results. Now using these P1 and P2, we can easily find out the R1 and R2 simply by multiplying P1 with Q1 and P2 with Q2. Once we have these two R1 and R2, we have the cost function already given to us. For the profit, we will sum up these two revenues, that is R1 and R2, and minus, and that is deduct the cost function from it. Then we will get this profit function, and this profit function will be differentiated with respect to Q1 and Q2 in order to get the first order conditions. Once we get these two first order conditions, we can simultaneously solve these two. That will allow us to get the value of Q1 and Q2. These are likely to be the critical values of quantity of the first product and the second product. This is the first product quantity and this is for the second one. Now we have found these two price equations already. These equations by using these two demand equations. So these price equations can be used to find the equilibrium price for the first product and for the second product. So this is what we have done here. P1, we have substituted the value of Q2 and Q1 and here of Q1 and Q2 to get the values of P1 and P2 respectively. So these are the two values of P1 and P2. We can use these values in order to find out the maximum level of the profit. So reminding ourselves of the profit function, which is this, we can find the answer of it by putting the values of Q1 asterisk and Q2 asterisk, that is the equilibrium values of first product and the second product. Here we have done this. You can pause the video and see that how these values are substituted, and this will give us the profit function, the maximum value of the profit, which is a positive value and it is likely to be a maximum value because it is based upon the process of maximization. Now we come to the next question, which is about this derivative. This derivative is the marginal propensity to consume, because this is the derivative of consumption function with respect to income. And once we get this, this is the answer of that, and we are also given the value of consumption function, which is 45 if the income is 0. This is logical because even if a person is not earning, he still have to consume the basic consume a little bit for the basic necessities of life. So the consumption function is to be found. This is actually the marginal consumption function. So we can write it like this, that is the derivative of cost function with respect to y. And then we have MPC, and MPC is equal to this. We have rewritten this in a more clear way. And then we have the integration of this, because if we integrate the marginal function, we will get the total function. So this is the integration with respect to y. You can pause the video and see the basic steps of integration. This is the constant of integration. It has a certain importance in this case. Because this is the consumption function. It is indeterminate because we do not have the value of c. It is arbitrary in nature. In order to find out the value of small c, that is the arbitrary constant or constant of integration, we will substitute the value which is given, that is y is equal to 0. Once we place y is equal to 0 in all these three places, the consumption function will be equal to 45. So this is why consumption function now is equal to 45. So both of these terms will reduce to 0, and now we can say that consumption function at no income is equal to 45, which is also equal to the arbitrary constant of integration. So now we have the value of this small c, which was the cause of indeterminate solution. Now we put this value and we get the determinate solution of consumption function. Now this was the determination of the consumption function that we did here. Now finally, the last question is simply about the inverse of a matrix, which is denoted by A, and this A needs to be solved. We know that the formula for finding the inverse of a matrix is simply the ratio of the adjoint of that matrix and the determinant of that matrix. Primarily you find the determinant because if the determinant is equal to 0, then the further solution will not be possible. So we are calculating the determinant of this given matrix, and it is equal to 98, which is not equal to 0. So this frees us from that worry of having a singular matrix, and we can go ahead with the solution. Now the cofactor matrix is this. You can pause the video and refer to that video in which I have explained the process of finding the cofactors, and you will get to know how these cofactors are calculated. Then we take the transpose of this matrix of cofactors, and it will become this, evidently, because this is going to give us the adjoint of the given matrix. So this is that adjoint that we were looking for in addition to this determinant, because their ratio will give us the inverse of that matrix. So we have found the inverse of that matrix as well, which was the requirement of this question. This question is mathematical in nature, no economic requirement is there, so the answer will remain less hardly interpreted. So this was the process of solving this final term exam of GCUL University Lahore. It was mathematical economics, its basics, its basic methods, and we have tried to solve all of these questions except for the one which was having some trouble with the solution. Might be due to some error in the typing of that question. If you have found it useful, you can give it a thumbs up, you can subscribe to the channel, and you can request for more of such solutions and suggested interpretations of various questions, question papers of economics, specifically mathematical economics. Thank you.